Cast is now starting. All attendees are in listen-only mode.
Good morning, everyone. I'm not sure if everyone can see me. I'd like to welcome you all to this first seminar on Christie Terra, part 1. We've had an amazing response. Thank you all for joining. There were well over 400 people that signed up from all across the world, from as far as Canada to Singapore to the Middle East, our Russian friends, all over Europe. It's been an amazing response, so thank you for that. First of all, I'd like to introduce myself. My name's Nick Weeder. I'm in charge of market development for Christie's video processing solutions. So that's Spider, Terra, Phoenix, and products like that for Europe, Middle East, and Africa. I am joined today with my wingman, who is Tom Booker, who's in charge of business development as well for Pandora's Box and Terra.
Welcome everybody. Welcome everybody from my side. Nick, when I introduce myself right now, probably can check your webcam because I can't see you. So probably some others can't see you as well. Yes, once again, hello from my side as well. It's impressive how many attendees are already online. Oh yeah, Nick, that's better. Yes, now I can see you.
There we go.
So the interest on Terra seems to be pretty high, which is something I absolutely can understand. Happy to have you all on board. I'm trying to answer your questions during the webinar. Maybe there will be a lot of questions with so many attendees, so we will stay online a little bit longer after the webinar is finished to answer all your questions online or through email afterwards if the questions get a little bit more complex. That's from my side. Nick, go ahead. Everybody have fun.
Yeah, thank you, Tom. So because there are so many people that signed up to this, which is, again, really great, please use the question tool that's available. So, just written questions, and we'll go through them at the end. And any questions that we can't answer or that take a little bit of time, rest assured, we will send those questions out after the webinar. So, part 1 of Christie Terra. So, in this part 1, I'm going to talk a little bit about the SDVoE Alliance, what it means, what the specifications are, why it exists, and so on. A little bit about the technology. Then I'll go into the Terra product line, Christie Terra, introduce you, give you an overview of what it does, different applications, and a little bit about the manager as well. And I'll finish up with a case study, which we did with the Zurich Opera House. And then we'll have time for questions as well. So today is going to be a bit of an overview of what the product is, what the technology is. So it's not going to go into too much sort of technical detail. Tomorrow, though, there's another webinar tomorrow at the same time. There we'll go into a little bit more detail about the different modes that exist, about networking, cable considerations, what you can do with audio, and there'll be another case study as well with talking about the Orange Satellite Control Center here in France, which is actually quite interesting because it uses a lot of different functions as well. And again, there'll be time for questions. So, what is SDVoE? SDVoE stands for Software Defined Video over Ethernet, and the Alliance, the SDVoE Alliance, is basically a consortium of technology providers. And the idea is to come up with a standard and a platform to be able to convey AV signals over a network and permit a software to define what you do with that technology, what you do with those signals, okay? So The Alliance was founded about 3 years ago now by 6 companies. Christie is a founding member, as well as Netgear, ZV, Sony, Semtech, and Aquantia. Semtech is the company that actually holds the technology. And these founding members constitute the board of the Alliance and define where this technology is going and what we're going to be able to do with it. There are many other members of the Alliance as well. There are about 40 in all, and companies are joining on a regular basis. There are 2 different levels of companies that join this. There are contributors, of which the latest ones to join earlier this year, Lightware and Analog Way, some big names you can see there, as well as Black Box DVI Gear and Ordinate as well. And there are adopters as well. There's very little difference between the 2. It's just a marketing thing. But all of these companies benefit from the technology. All of these companies have access to the same technology platform. So SDVoE specifications. The first one is 0 latency. We want to be able to convey or transport video over a network with very, very low latency, 100 microseconds, which is 1/10 of a millisecond. That's the first thing. It's the most important thing. There's a comprehensive API to be able to define what you do with those signals. Uncompressed transport for all video signals from HD to 4K 30 over a network, and artifact transmission of 4K 6444 that is indistinguishable from the original source, and more about that later on. Multi-audio transmission and independent routing, that's important. So the audio doesn't necessarily have to follow the video. RS-232 and infrared transmission and independent routing as well, so you can route those signals from one point to another, again separate from where they come from. And there's also a gigabyte network that sort of resides on this SDVoE transport, 10 gigabyte transport pipe. Another important thing is the interoperability between vendors. So all of those 40 companies that are part of the Alliance can all develop products based on SDVoE technology. All of those products are interoperable between themselves because the API and the resync clock and the session management is the same for everyone. So you're not locked down to any one specific vendor with SDVoE technology. You can go and mix and match products from many different companies, and all these products, these SDVoE products, will be able to talk to each other. You also get, and this is a kind of software part, you also get broadcast quality scaling and downscaling with aspect ratio management and frame rate conversion between the source and the destination. You also get display wall processing with bezel compensation and microsecond sync, so that your video walls, your flat panels are all synced together. And you also get audio, multi-channel audio downmixing to stereo. And again, more about that tomorrow. In tomorrow's presentation, it's a little bit more technical. So I talked about the latency. This gives you a quick overview of how fast SDVoE really is. As you can see, even with 4K 6444, the latency is extremely low, still at 100 microseconds. When you compare that to other standards that everyone is familiar with, like JPEG or H.264, you're talking about up to 1,000 milliseconds instead of 100 microseconds. So this means that it's pretty much instantaneous, and there are functions that SDVoE can be used with that are very difficult to use with other other standards, that take much longer because you have to encode the source, transport it, and then decode at the other end. So SDVoE is really the first network-based systems for zero latency AV transportation and distribution, uncompressed 4K 3444, and pixel pipeline compression for everything that's above that, where only a few pixels are compressed and not the whole signal. That's a big difference between SDVoE, for example, and something like H.264, where the whole of the video signal is compressed. With pixel pipeline compression, we're only compressing a few pixels, okay, just to be able to squeeze it into the pipe that we need to. It's also the system, the base system for audiovisual USB, RS-232, and infrared and audio switching and distribution, and also signal processing, because we can scale. There's also multi-viewer, which you'll see later on, and also you can build video walls from it as well. So the SDV was really the foundation for the decentralized network-based matrix switching and video processing, of which Terra is Christie's first product, SDVoE product. So what is Terra? Terra is Christie's solution to build matrix switch or multiple matrix switching control and processing and a KVM platform that works from a 10 gigabyte network. Again, it uses uncompressed AV using SDVoE. It's highly flexible and a scalable platform because it's network based. And Christie is applying this technology, this SDVoE platform, across many products from source to display. So it really is becoming a matrix switcher, or a multiple signal matrix switcher. So it's different functionalities here. I've talked about switching, also extension, control, and KVM as well, which is a big advantage. And one of the key things is the zero latency for the KVM function. Video walls, multi-viewer to also preview your sources, and source and destination match as well. And there are three there are three elements to the Christie Terra product line. The first one is the Terra TX, the Terra transmitter. Okay, TX is a transmitter, and RX, which are terms that I use a lot, is a receiver. So on the transmitter side, the Terra TX, there are two inputs. One is the HDMI 2.0, and the other is DisplayPort 1.2. Okay, and you can switch between the two, and so you can actually connect a source to each of these inputs and sort of alternate between one and the other. The next, then you have the SFP plus transceiver or plug. This is where the SFP plus transceiver fits. This actually gets connected to your 10G network. Okay, so this permits the very high bandwidth transmission. There's a RJ45 connector, again, to be able to take advantage of the gigabit Ethernet, the sort of Ethernet network sort of resides on the back of this 10 gig network. There's a USB connector as well, and that can be used for KVM keyboard, video keyboard and mouse, for example. It can be used for other things as well, such as hard drives and USB cameras and stuff like that. So it's anything that is USB 2 will work on this connector. It is full bandwidth, and it's also bi-directional as well. So it doesn't necessarily sort of go from TX to RX, from transmitter to receiver, but it also can go back the other way. The external power supply is where this connects to. There is also a 1 rack unit power supply that can power, I think, up to 10 TX or RX units. That's available. The RS-232 for control. Now, this is not to control Terra per se, but to control devices, other devices that are connected to the Terra TX or RX. Infrared as well. So again, that's bidirectional. Now that can give you control, for example, over flat panels. If you want to use your infrared control for flat panels and so on. So you can do that remotely. And here you've got an audio, a bidirectional audio connector that can either be an input and an output. So more about that technically on tomorrow's webinar. And again, on the front, there are 5 different LEDs that sort of indicate what's going on and the health of the unit. So you'll be able to see if there's the KVM function is active, whether it sees video or not, whether it sees the network or not, and so on. There are 2 buttons on the right. Only one's actually used for the TX, and what it does is just switch between the inputs, the HDMI inputs, and the DisplayPort input. Now the Terra receiver, the RX, is pretty much identical to the TX, except for it only has one output. It has one HDMI 2.0 output. The other connectors are all there. The USB connector is a USB-A instead of a USB-B. And again, this is bidirectional. But again, everything, all the other connectors are exactly the same. The third component in the Terra world is the controller. Now, this is a very important part of the system. So the Terra controller is run using the Terra Manager software, which installs on a PC or a laptop. It holds the system configuration. So it holds all the information on, the video walls configuration and the other destinations that you have, whether it's a projector or a flat panel. It also holds the source configuration and so on. You also use the controller to be able to configure the transmitters and the receivers and give them IP addresses. Each TX and RX require 2 IP addresses, and the controller is able to do that. It sort of auto configures them automatically. It goes out and finds all the SDVoE devices that are connected to the network, and you can get it to assign all those devices to IP addresses automatically. So it manages those devices, and it helps you update and swap out devices that maybe have failed, if that should happen. So you can swap devices without having to redo presets and layouts and so on. It has a very comprehensive EDID manager as well. So it makes source management very, very much easier with this. So it communicates with the RX and the TX, and what I mean by that is that it tells the transmitters and receivers what to do and when to do it, and more about that later on. It stores layouts, or I mean, you could, I guess, call them presets that you can recall at any moment. The controller is can also be controlled by a third party, by an API, using an API. So that can be a Crestron, or it can be the Christie widget designer as well. So you can build your own bespoke interface very, very easily using the API. You can also configure a backup controller, so you can have controller redundancy in your system. That makes the whole Terra system extremely resilient. There's also a web-based XY panel. So there's like a web interface of the controller, and this pretty much reproduces the standard, like a standard matrix switcher sort of interface where you have inputs and outputs. So the TX are the inputs, the RX are the outputs, and you can select the type of signal that you want to switch and where you want to switch it. And it works pretty much the same way as the front panel on a standard video matrix switcher works. Some of the other products that we have that are based on SDVoE that are available or coming up, we have the Terra SDVoE input card, or we call TSIC. Now, this is an input card for some of our projectors, the Boxer range, the D4K40 RGB laser projectors, the Mirage SST, Boxer 2K, and Crimson. All of those can now have a TSIC card, so you don't actually need a receiver. You don't actually need a Terra receiver to be able to feed these the video and even control into these projectors. So that sort of does away with part of the hardware. The Christie E1100 LED controller also has an SDVoE input, and this is used for the Microtiles LED product, which is being very successful as well. So again, you know, the LED controller has an SDVoE connector. You don't need a receiver. It makes the installation very much more easier to do. It's very much lighter. You have less hardware. It gets more resilient, and of course, it's much more cost effective. We're also under development as well as an SDVoE input card for flat panels that would slot into the OPS slot, but that is that's going to come up, you know, later on, maybe later on this year, maybe next year. You know, right now everything's a little shaky with this the coronavirus thing, so I don't have a date for this, but it's certainly under development. So Christie has a whole SDVoE ecosystem that exists from source to display, and including control, and all of this is connected via a standard 10 gigabyte network switch, So you can have all of these different solutions, display solutions, connected to the same architecture, the same network system. So whether it's tiled view displays or projectors or image processing, or whether it's other devices from other partners in the alliance, and everything can be connected together to create a very flexible and powerful audio-visual switching ecosystem. So the Christie Terra functionalities include, like I mentioned earlier, system-wide EDID management, which is very important. So you can apply EDID files very specifically to specific transmitters. You can go and grab an EDID from a specific transmitter that's connected to a bespoke display and send that to certain transmitters. So it's actually pretty good. You can even load your own EDID files and into the system and apply those to transmitters as well. So it works very, very well. It's a very powerful EDID tool. Terra fully supports HDCP 2.2 and 1.4 as well. Anything that's HDR or deep color, Terra will preserve this data, and it will, from transmitter to receiver. So no problem with that. I've talked about the JSON API for third-party control systems. We get a lot of feedback. Christie Widget Designer module for Terra is also available. There's a Creston module available as well. It's encrypted so that anything that goes over the network switch remains secure. We're talking about mathematically lossless processing, even 4K 6444, which we do have to compress just a little bit. And again, you know, we only compress a few pixels. All the data that is actually fed into the TX gets reproduced at the destination, and it's artifact free. And you can use the RS-232 and the infrared and the gigabyte Ethernet to be able to control other systems, you know, across the network. So I'm going to go into some of the applications that you can use with Terra. And the first one, which is pretty much very basic, is extension. So you could, in fact, take a transmitter and connect it directly to a receiver using the SFP Plus connectors and just a fiber or a copper cable between the two. And whatever you inject into the transmitter comes out at the other end. So, you know, 4K into the transmitter, you get 4K out on the receiver. So they are gen-locked together. But you don't only get this on video. So in the example at the bottom, you can actually use the Ethernet connector in this example to be able to control the projector at the other end. So you have, on the left-hand side, you have a media server that is connected to the, for example, the DisplayPort input on the transmitter, and that video gets sent across directly to the receiver. And at the other end, there's an HDMI output that is connected to the projector, and whatever you input to the transmitter gets sent across to the receiver, and that's what's sent to, in the end, to the projector. Okay, whatever. So if it's HD into the transmitter, then HD goes into the projector. You can also grab. There's a button on the front of the receiver that you can also grab the EDID file from the projector in this case, and send that to the transmitter so that the media server or your source will be able to output the correct resolution for whatever display device you're using, whether it's a flat panel or a projector. So you can do that as well. Also, you can see there's a laptop there. Now, the laptop's connected to the transmitter using a normal Ethernet cable. And there's another Ethernet cable that is connected between the receiver and the projector. So you can actually access the web interface on the projector using the laptop as well. So this is one example of what you can do with that Ethernet network, as it were, that piggybacks on top of the SDVoE 10 gigabyte network. You also have USB and audio and so on, an RS-232. I haven't illustrated that here, but you could also connect those up as well. So this is pretty much it's the most common application for Terra is audio-visual switching of audio and video, and it's highly scalable. It's highly scalable. Why? Because we're using an Ethernet. We're using a network switch. Okay, that network switch can be as big as you like. It's not rocket science. If you run out of ports on your switch, you can piggyback and connect switches together and add destinations or sources. There's really no limit. So in this configuration, you've got format conversion. You've got scaling on the receiver end, so you can tell the receiver what resolution you want the output to be, and whatever the source that comes into the receiver will get scaled to that output. You've got breakaway audio and control. So again, just because you send a video signal from transmitter A to receiver A doesn't mean to say that the audio has to follow the same path. You can route the audio and the USB and RS-232 to different destinations from the video. So this makes the whole system extremely flexible. So it's a very cost-effective way of switching different types of signal around different destinations. So instead of having multiple matrix switches, like an HDMI matrix switcher and a DisplayPort matrix switcher, a KVM switcher, and so on, all that is replaced by a simple 10 gigabyte network switch. And again, you can expand this over time. There's no limit. You can link switches together. With a standard AV matrix switcher, you have a fixed number of inputs and you have a fixed number of outputs. And once you fill all those inputs and outputs up, then you're blocked. You cannot add anything. You have to change the switcher for a bigger model. With this kind of technology, all you need to do is add a network switch. It's very, very cost effective. So another application is for video walls. Now, this is a small example here. This is a 2x2, but you can build them, any size you like. And you have so each tile or each flat panel or each LED controller, if you're doing LED walls, would have a receiver, or it would at least have an SDVoE input. Okay, now those receivers are locked together. They are gen locked together. The SDVoE sync are locked together. So you can actually take a single source and spread it across the whole of your video wall, and there will be no, there won't be any sync issues between each of the tiles or the flat panels or whatever you're using. It's got broadcast quality scaling, and you can also recall layouts to be able to change what you're seeing on the screen. Maybe you have something that's full screen, a source that's full screen, but then you can also have something that is where you have a different source for each quadrant, for example. And you can control that using either the Terra Manager software or using the API. One of the other applications, another really interesting applications, is the multi-viewer. Now, the multi-viewer, you can actually display up to 38 different sources on a single output. Now, this is a little bit specific. The transmitters and receivers have broadcast quality scaling, and what this does in this instant is, and I'll go more into depth about that on tomorrow's webinar, but the transmitters actually sort of publish or transmit the source twice. So once in its native resolution and once in a scaled down version. And what the multi-viewer does is it actually subscribes to the scaled version on the transmitter. And you can get the receiver to subscribe to multiple transmitters at the same time and build your multi-viewer like that. And again, you can use layouts to change the setup and what you're seeing and so on. And you can also control it using, obviously, the API. Another very interesting feature of Terra, and this is also down to the fact that the latency is very, very low, is controlling KVM. Now, what we have here is you've got all your sources, all your PCs and so on the left-hand side. And you can imagine, for example, a control room, and tomorrow's case study actually illustrates that. You can have a control room with all your PCs and sources in a rack, in a technical room, and then in the control room in each position. All you would need is a receiver, a keyboard and mouse, and a screen. And you can switch the USB from transmitter to different receivers, from different transmitters to different receivers. So you can take control from any point, from any receiver. You can take control of any of the sources that are connected to the switch. So we have a USB matrix switcher for all intents and purposes. So any point, any receiver can be a KVM control point. And the USB can be used for many different types of devices, whether it's a thumb drive or an external hard drive, or even a USB security device that you need to be able to unlock, for example, unlock a certain source, a certain device. And Terra is able to give you the full USB bandwidth of 480 megabytes per second. And the reason that I mention this is that a lot of the other systems that are available on this, today that sort of send video over Ethernet on 1 gigabyte, on gigabyte networks, you cannot get the full USB bandwidth, because they have to compress the video, and the video takes up so much bandwidth within that 1 gigabyte pipe. Now, all of those applications, you can have them all at the same time on the same network. So you can have touch screens, you can have multi-viewer, you can have your video walls and your KVM access, and your projectors in different rooms, on different floors, even in different buildings, all of them connected over the same 10 gigabyte network. It's very, very simple, and it's very, very cost effective. So Terra does all of this at the same time. It's a very powerful, very flexible system. As you can see from this image, you can use different types of cables, some copper, some fiber, depending on the lengths and where they are and what you already have and so on. And the whole system can change as well. And more about that in tomorrow's webinar, where I'm going to be going into the different modes that the receivers have and how you can switch from, live, switch a receiver from one mode to another. It makes the system extremely flexible, extremely powerful. So a little bit about the Terra Manager software. I would have loved to be able to do a live demo for you, but we actually need a controller, and I'm in lockdown in France, so I don't have access to one. So there are things I can't show you, but the software is very, very easy. It's incredibly easy to do, to use. It's pretty much drag and drop. Okay, so obviously it interfaces with the Terra controller, but it's very, very much drag and drop. It discovers all the SDVoE devices on the network, so you don't have to go and find all those devices by yourself or configure them offline with an IP address and then connect them to the network and then go and find those. No, you don't need to go through all of that. The controller and the manager software, they'll do all of that for you. They'll set up the IPs. And they'll update the firmware if you want to do that as well, very, very easily. That doesn't mean to say that if you don't want to do that, that you can't do it manually if you want to be able to do that, but it can do it semi-automatically. And the reason I say semi-automatic is that you can select the devices that you want to work on at any one time. You can select certain transmitters or certain receivers, and certain receivers, and update them or swap them or give them IP addresses or give them a name. Okay. You use also the software to manage the audio, what you do with the audio, if you want to breakaway audio, or you want to use the audio connector on the TX as an input or an output or a loop through. You use the software to configure the RS-232 connectors and how you want that set up, and USB, what you want to allow on the USB connectors, whether you want to allow everything or you want to lock out hard drives, that kind of thing, or mass storage devices and just have KVM and so on. It holds the EDID manager, which I talked about earlier on. You can save layouts, which is very important. So you can recall layouts either using manager or third-party API, your Crestron or widget designer interface. It also has reset functions, so you can reset devices or the whole system. You can manage the backup controller as well, and you can create backup files, which is in some instances very important. And actually the case study that I'm going to be talking to you about shortly actually depends very much on the creation of backup files, because they have a lot of different shows with different setups. And obviously you can restore the backup files as well. So it's very dark, and this is over Ethernet, so I'm not sure if you're going to be able to see much here. But this is the configuration part of the software, where you create your destinations, your video walls, or your projectors, and so on. And on the left-hand side, that list there, where you see all those little sort of numbers and letters, that's in fact MAC addresses. That's your list of receivers. Okay, so you actually go out and it actually finds all the receivers here on the network, and those on the left is that list is a list of receivers that are available on the network that have not been assigned to a destination, a video wall, a projector, or a flat panel, whatever. Okay, and you literally drag and drop those receivers into the destination that you want, and it sets that receiver up. Okay, but again, we'll be organizing a training session specifically for Terra Manager shortly, within the next, week, 10 days. So stay tuned for that. It's really interesting. There's a lot I can't go into today because we're offline, but we're working on a solution to be able to do that. And I think we found a solution. So yeah, stay tuned. There's going to be a training session on the Terra Manager, or at least a presentation, a demo. This is the operation, the operation mode of the Terra Manager. So on the left-hand side in green, now you have the list of transmitters or the list of sources. And to be able to switch a source to a destination, you just drag and drop it into a window. That's all you do, and it switches. It's really simple, very, very simple to use. This is the global settings. So this is where you sort of give your controller its name, its IP address, and so on. This is where you create your backup files. You can manage the devices, download logs, and restart the system and reset and so on, and even delete the system configuration if you're in the rental and staging industry and you want to wipe the configuration clean and start again. It also enables, the different types of control, the JSON API and the XY panel and so on, or VNC and the web browser and so on, that you want to use to be able to control it. Very, very easy, very simple to use. So that, in a nutshell, is a sort of brief introduction to Terra and the Terra product, its capabilities, its functionalities, what you can do with it. What I'm now going to do is to talk to you about Zurich Opera, which was the very first Terra installation that we did. It's over 2 years now, I think. 2 years ago. So this is the Zurich Opera in Switzerland. Beautiful building. And this is the inside. You can see how wonderful the building is. And they had some very specific requirements. So they had a new stage production that required 4K content and projection. And what the artistic director wanted to do was to have live camera inputs of the actors on stage, the singers on stage. He wanted them to be displayed on various screens that were going to be hung in front of the left and right balcony. That's where you see those white sort of triangles or pyramids, as it were. So that's what the projection cone was going to look like. So they were going to suspend a whole load of screens there, and they needed to be able to send content to those screens and also to be able to send live camera. So they needed very low latency because they were using cameras live. They wanted to be able to use existing fiber infrastructure that they had. So they already had fiber there, multi-mode fiber. It had to be easy to use and reliable. Now, one thing that they do is they actually changed the configuration, or they changed the show that they do twice a day, because in the afternoon they will rehearse one show, and then in the evening they will actually do another show, a different show in the evening. So they're constantly building up and breaking down, every day, twice a day, because they actually rehearse the next show while the current show is actually running. They also needed a lot of adaptability to be able to do that, to be able to change, the content and the resolutions and where, projectors were and so on and so forth. And also needed scalability to be able to adapt to future shows as they sort of increase the amount of video destinations or video sources that they need. So they're in existing infrastructure. They already had three box of 4K projectors. They already had Pandora's box media servers as well. And at that point, they had a point-to-point fiber extension to various endpoints around the theater, but they didn't have any distributed control. They didn't have any way of distributing those signals around very easily. And the challenges were several. They needed to be able to find the best way to project the content onto the screens, to insert live camera feeds onto multiple suspended screens each side of the house, both in portrait and in landscape simultaneously. They need to be able to preview the content and the sources, especially the cameras. They needed to be able to retain control of the media servers and the projectors and the signal switching from a single point. And like I just said, the operational requirements were quite stringent. They needed to tear it down twice a day to be able to go from rehearsal to the evening show. So they need to be able to reconfigure the whole system very quickly between rehearsal and evening shows. And this is where, you know, the Terra backup configuration files become very, very useful, because they were creating backup files for each different show and then loading the backup files very quickly to be able to switch from one show to another. So this is the design that we ended up with. So there are sort of three main areas that were defined. One is the technical room, which was tucked in away in a corner in a sort of a back room of the, and even I think it was up several floors as well, tucked in a back room in the opera. And this is where all, you know, the media servers were, and the networks, the main network switch was. And the switch they use was a Netgear M4300 96 port switch. The switch wasn't totally full, so there were 96 ports used up. It actually has modules, and they were, but they wanted this 96 port card frame to be able to add modules to it as their, you know, their requirements grew in size. Okay. The good thing about this particular switch is that it's SDVoE compatible out of the box. But I'm going to talk more about the network side on tomorrow's webinar. So join me for that to learn a little bit more about that. So in the tech room, there was a whole load of Terra transmitters connected to the outputs of the Pandora's box media servers, connected to the switch using copper cables at this instance. This is where the controllers were as well, and there were two, so they have a backup controller connected, also connected to the switch for redundancy. And there were actually there were more than two. I think there were 4 Terra receivers, because they had in fact 4 cameras in-house. So 4 Terra receivers were also in the rack. On the on stage and in-house, now this is where the other sort of the endpoints to the fiber was. So back in the tech room, the endpoints that arrived, the fiber endpoints that arrived in the technical room were just connected to the Netgear switch. Okay, to ports on the Netgear switch, to the SFP plus connectors. That's all they had to do. At the end of those fiber cables, they were we connected the transmitters now that were connected to the projectors and so on. So, and the projectors moved around all the time. So each projector has a Terra receiver that's assigned to it. And so the Terra receiver follows the projector around, whether it's on the balcony or it's upstage behind the stage set or wherever. And the Terra receiver is just connected to a fiber endpoint on stage or in-house. It's as simple as that. The cameras were also connected to receivers over HDMI, so they were using the an SDI HDMI converter to be able to connect directly to the transmitter. And again, the transmitter, the TX for the cameras, were connected to a fiber endpoint in-house, which was obviously then which would connect up to the Netgear, the main Netgear switch in the technical room. Now, up in the control room, There was a second switch, a smaller one, an 8x8 Netgear switch. And there are two receivers connected to this switch. The receivers connected to two different screens, two different monitors, so they're able to to switch the receiver into multi-viewer mode, to be able to look at what the cameras are showing. They'll be able to put it into fast switch mode so they can see exactly what and the output from one of the quad server outputs are doing. So they have total visibility, complete visibility in what all the sources are doing. So when the output of the quad server was being switched to one of the projectors, so routed to a projector, it can also be routed directly to the control room, to the receiver in the control room, so they can also see what the projector is receiving as well. So they have complete visibility over all the sources, as at the same time as the sources are being routed to their destinations, to the receivers, to the projectors. They also had two PCs connected to the switch. Now the PCs were used to control the Pandora's Box media servers and also to control the projectors. And you'll notice that there's an Ethernet connector between the receiver and each projector, and they are able to access the web interface on the projector from any of the PCs that are connected in the control room. The projectors aren't even in the same IP range as the Terra transmitters and receivers. They're a completely different IP range. But that doesn't matter, because they're using the gigabyte Ethernet network that piggybacks on top of the Terra network, the Terra 10 gigabyte network. A little more about this tomorrow. So they have complete control from that room, complete control over all of their devices, the projectors, the media servers, the switching. They can look at all the sources. They can have multi-viewer mode to be able to see what's going on several sources at the same time. It's extremely flexible. The implementation process was really easy. The first thing that you do is just connect the transmitters, the receivers, and the controller to the switch. So the transmitters and receivers connect using SFP plus connectors. The controller connects using a standard RJ45 gigabyte cable. And then you start everything up. You start the controller, and then you power up the TX and the RX. The next stage is to configure the transmitters and the receivers. And the software, the manager, does this by itself. So you can go and select the transmitters and receivers. It'll go out and find all of them. The transmitters and receivers at that point have a DHCP IP address, and we need to give them a fixed IP address. Okay, and the TSA, the software, will actually do that by itself. Okay, so you can actually define the IP range that you want to use for the transmitters and receivers, and the controller and the software will go and automatically give an IP range, assign an IP address, sorry, to each transmitter and receiver. In this instance, however, the Zurich Opera didn't want quite the same IP range for the transmitters and the receivers. So I couldn't use the sort of the semi-automatic way of assigning IP addresses. So I had to do it manually. I mean, it was very straightforward, very, very easy to do. It just took a little bit longer to do that. Thankfully, there weren't thousands of them. but it's incredibly easy to do. Once that's done, then all you need to do is to configure the destinations. So the destinations, in this case, there were 3 projectors and 2 screens. Very simple to do. Once that's done, and you've dragged and dropped the each receiver into the destination that they're assigned to, then you just create layouts. And once creating layouts, you drag a source onto a screen or onto a destination, and you save that as a layout or as a preset for you to recall, either using, again, the manager, which is what they're doing, or using a third-party control interface. So this is a picture of the rack in the control room, and you can see the these are the transmitters that are there. They're connected to the Pandora's Box media servers. At the 2 bottom boxes down there, those are the controllers. Okay. What you don't see in this particular photo is the 96-port Netgear N4300 switch. The cables that were being used between the transmitters and the media servers were copper twin-ax cables, and also but then on the other end you had the fiber cables that were coming in for all the different points around the theater, around the stage and in-house, that were coming up into the control room, and those were also connected to the switch. This is a picture of the control room now with the Netgear 8x8 4300 series switch, which is actually under the desk you see there. You can see that on the top right-hand side, you can see those are camera feeds, actually, 3 of the cameras. That's one of the receivers that's in multi-viewer mode, and it's looking at 3 of the cameras currently. On the screen on the right-hand side, you're actually seeing 2 different interfaces. The small one in the center, one of the projectors, and so that's the smaller window in the center of the screen. In the background, you're actually looking at the Pandora's Box manager that's used to control the media servers. On the left-hand side, what you're looking there on the laptop, that is in fact the Terra Manager software that's running and controlling the switching for the whole system. They were using 2 fiber links, just 2 fiber links between the 2 switches, between the 8x8 and the 96-port switch. That's more than enough. The reason why they were using 2 links instead of 1 is because they're actually using 2 receivers, and they've got a lot of 4K content. So it's down to having enough bandwidth between the 2 switches. I'll go more into about bandwidth and that kind of thing in tomorrow's webinar. So I'm strongly invited to join me for that. But it's a very, very simple, very simple system to install. It's very much plug and play. There was no configuration required at all on the Netgear switches because they are SDVoE compliant. It was literally plug and play, and they haven't touched them since, even the 2 links. And it took longer actually to set up the outputs, on the right resolutions on the media servers than it actually did to set up Terra. So it went in very, very easily indeed. And this is the result. Okay, so you can see I've just illustrated the projection throw of one of the 4K projectors that's tucked up in a balcony there on the left-hand side. And you can see that some of the screens are different sizes, different aspect ratios. So what was happening is that the reason why they needed very low latency on the cameras that you're seeing on the screens here is that we had to inject those camera feeds into the Pandora's Box media servers in order to be able to put them onto the sort of tiles, as it were, into layers that were the right orientation and the right aspect ratio so that we could project them onto the screen. So you can see, very, very impressive. And they literally built that up and tore that down twice a day during rehearsals. So that's pretty much the end of my presentation. And a few photographs from photos from the Zurich Opera. You can actually see what was sort of close up what the camera feeds did. They're very, very happy with it. It was delightful to be able to receive a call from our friends at the opera a few days later, just to say thank you. Because it worked really well. And they've now migrated from having a receiver on the boxer projectors to using the TSIC input card. So now the three receivers that were assigned to the three boxer projectors are now being used for other destinations, and the boxers now have the TSIC input card. A few other Terra projects in EMEA. I mean, it's not all of them, just some of them. So I talked about Zurich Opera House. The National Opera and Ballet in Amsterdam also uses Terra. Dubai Expo 2020. They're building a big control room for the police and the armed forces down there. It's going to be using a Terra. Orange Satellite Control Room I'm talking about tomorrow. EACAD is in France, it's in Strasbourg. This is an installation. It's a medical installation for EACAD, who do a lot of sort of cancer research. Stereolux is also in France, and that's like a bit like the sort of probably based on the same kind of thing as the Opera House. It's a venue where there are several sort of music stages. They do several concerts and so on, and they actually have switches and receivers and transmitters in little flight cases that they can move around from one stage to the other, as well as having a centralized switching system. So they can sort of switch content and camera feeds and so on around the building. We've installed them on cruise ships as well. Pixel Fixation is a rental company in the UK that uses them extensively for their shows. Discovery Channel uses Terra in their building in London. I mean, these are just a few examples of some Terra projects in Europe, Middle East, and Africa. So to summarize, the three sort of key points that I'd like you to go away with, that I'd like you to remember about Terra, is its performance, its latency, and the image quality that you get. Okay, so it's lossless. There's no loss of quality, and it's really, really quick. Its scalability, because we're using a network switch. We're not doing anything that that's different from basic network configurations or networking architectures. It's the way you set up the network is the same that you would set up a gigabyte network, but it's just like 10 times more. It's a 10 gigabyte. So it's scalable. It's completely scalable because of that. It's also very much affordable. It is a lot cheaper than using the same functionalities, than getting the same functionality, sorry, by using standard AV, video matrix switches and audio matrix switches and KVM matrix switches and so on and so forth. It is much, much cheaper. And just to illustrate this point, when we joined the Alliance, when we created the Alliance with our 5 other partners in this adventure, we went to see NASDAQ. And I guess you're all familiar with the huge NASDAQ hall, which I think from memory has 96 different screens. And we told them about, what Terra could do. And the NASDAQ right now has a massive amount. I mean, rack after rack, a huge audio-visual standard matrix switcher, and it's millions of dollars worth of equipment to be able to switch sources around that massive video wall. We quantified, a Terra solution for it, and it turned out to be half the price, literally half the price. So it's very affordable, and it's scalable, and it's much easier to install. It's quicker to install. It's more, it's more cost effective. The cost of ownership is lower as well. It generates less heat. It uses less, electricity and so on. And so SDVoE really offers the same quality and latency as your traditional matrix switches, but it gives you more functionalities, greater flexibility and scalability. And that's why the Alliance is growing with new adopters every year. And the fact that companies like, Lightware and Analog Way have joined recently is a big sign. And we really think that SDVoE is going to become, if it's not already, the future standard for video over Ethernet. So that concludes my presentation for today, this brief introduction to Terra. I hope you'd enjoyed it. Now we're open for questions. So Tom, if you're still with me, I'm going to jump back. I don't know if there are questions or not, but let me know.
There have been a couple of questions. So my fingers are hurt. I was not able to answer all your questions, but we will stay online and taking care of the questions I was not able to answer right away.
What have we got?
How many questions?
What questions do we have?
A lot of questions regarding network technology. Talking about subnets and if we can max VLANs or use the existing company network and what are the requirements. So a lot of network stuff that we will talk about in tomorrow's webinar, which I hope most of you guys will enjoy, will join tomorrow as well to get more information on the network stuff. So yeah, that definitely was something people were interested in. So far,
is there anything? Are there any questions that we can answer while we're still here for everyone?
Let me go.
So, for example, go ahead.
For example, some more questions have come up regarding the hardware. For example, why we do not support SDI on the inputs side, or talking about the USB connectors being a 2.0 connector on the current Terra devices and why it's not a 3.1 connector. And I can absolutely understand these questions. Right now, we're talking about the first generation of Terra hardware, and you're right. It's USB 2.1 and 2.0, and it does not offer SDI inputs so far. What we hope for to see, hopefully soon, is USB 3.0 and SDI inputs on the next Terra hardware generation. And before you ask when this is coming up, I don't know. Hopefully soon. Yes, so network hardware, a lot about how to set up a video wall. So a little bit about how to use the Terra Manager. As Nick has already mentioned, we are planning to make another webinar talking about the Terra Manager. Only believe me, this will be a short webinar because I have never seen a more easy to use and intuitive software like the Terra Manager. I absolutely love it.
It's very, very quick. It's very easy to use.
Absolutely. So literally, this will be a quick webinar, but we will do a separate one for that. Some questions, I have to admit, I have to do a little bit research before I can send you an answer, especially on the deep technical network stuff. So I don't think that these are questions we can answer.
So talking about VLANs, for example, you can actually create different VLANs on the same switch. So if you've got a Netgear M4300 96-port switch, you can create VLANs within that switch and assign ports to those VLANs, so you can separate, for example, certain transmitters and receivers from others. So there's a whole load of things that you can do.
And that was a question from Sudeepa. Sudeepa, and thank you for joining the webinar. Can we control transmitters and receivers on different VLANs, or all has to be on the same VLAN? That, for example, was one of the questions.
You can do both. I mean, in its simplest form, if you're using the Terra as a sort of a video matrix switcher, then you would have just one VLAN for all your sources and destinations. But yes, you can break it up into different VLANs. Again, this is we're using networking technology to be able to convey this over the over a network. So it's not rocket science. We're not changing anything. We're not you don't have that. We're not getting you to configure network switches in a specific way that they're not supposed to be configured. It's really basic networking 101. It's really simple. So yes, you can split your network up into different VLANs, I don't know, for different buildings or different rooms or whatever you want. Yes, you can.
So another question from Jonathan York is, can the RX and TX and the controller be in different subnets? If so, can streams be multicast across the different subnets? Another nice network question. I don't think so. I think the subnets has to be the same.
No, they need to be able to see each other. They need to be able to see each other. So although you could probably configure the system to be able to do something like that. But that would take that takes a little bit more in-depth network programming.
Yeah. Another question was, for example, can a controller be controlled with a third-party control device for a touch panel control?
Yes.
Of course, you have mentioned the Crestron technology. Maybe this is a good chance to introduce the wonderful widget designer, which is another possibility to control the controller.
So,
yes, I know. Just
there is a Crestron module available for that, and there's also widget designer, which also has. Widget Designer is a great piece of software. It's probably one of our best products that we have. It's a little bit of it's a piece of software that basically interfaces between anything, any two devices. It doesn't matter whether it's MIDI or DMX or Terra or Ethernet, you name it. It will sort of connect those devices together and control them.
Absolutely.
And you can define your own sort of web GUI and web pages and using HTML5, I think it is, Tom. Correct me if I'm wrong.
No, that's right.
It's an incredibly powerful tool with which you can you can control literally everything, and you can get other devices to control it as well. So you can trigger. You can trigger things using contact breakers and stuff like that using Widget Designer. So I strongly suggest I can only say go and see go and have a look at the Widget Designer webinars. I don't know if we're still doing those, Tom, but
sorry,
it's a great piece of software, well worth that to have a look at.
Absolutely.
I love it.
Absolutely. For the 10G network, what is the limitation for the quantity of TX and RX units in the network? This is a question we get quite frequently.
Okay. So there's no real limit. I mean, it's the number of ports that you have available on your switches. So the most important thing, and again, you know, we'll go into this in a little bit more detail in tomorrow's webinar. So long as your 10 gig network switch is non-blocking, so you can load up the switch, each port with 10 gigabytes, whether it's a TX or an RX, a transmitter or a receiver, then you're fine. There's no real limit. It's the size of your network that's the limit, which is the huge advantage over this type of technology against your standard AV matrix switcher, where you have, I don't know, 64 in, 64 out, and once you've used up those 64 inputs or outputs, then you're stuck. That you don't get that with SDVoE. You don't get that with Terra. Build your network any size you like.
Two more things that just came in, kind of simple. Time of tomorrow's webinar. We will start at 11 o'clock. Just like today, we will start at 11 o'clock with the second part of the Terra webinar tomorrow. Hope that you will join us there. Another quick one is, what is the Terra SFP Plus trans receiver? The Terra units are coming with an SFP Plus LCLC multimode connector. This is part of the delivery that you will receive with a Terra device. If you want to use other SFP Plus connectors, you are absolutely free to get them and to use them with the Terra devices. That's not a question.
Yeah, we're going to talk more about different SFP, different types of SFP Plus connectors and so on, cables in tomorrow's webinar. So please join us.
That's it.
Join us tomorrow for that. Again, 11 o'clock. 11 o'clock on the dot tomorrow morning.
And that's it. And as I said, the questions coming right now are all kind of network related. If we have a source, one sent to a video wall, can we then have the source one as a part of a multi-viewer along with other sources? The answer is yes.
The answer is yes.
The answer is yes.
The answer is yes.
Absolutely.
Because the TX, the transmitter, publishes the source twice. So once in its native resolution, we call it stream 0. So if you have an HD input on the transmitter, then stream 0 is going to be HD. If it's 4K, then stream 0 is going to be 4K. It also publishes a scaled version of that source in what we call stream 1. Okay. So stream 1 is a scaled version, and that's also available. So yes, you can have a source, from transmitter A displayed on your video wall, and have that same source being displayed in a multi-viewer at the same time. Again, this is a matrix switcher, so that stream 0, that fourth stream 0, is available for all the destinations at the same time. Okay, so you can get all the receivers that are on your network to subscribe to the same source at the same time. Okay, it really is a matrix switcher.
Okay, Nick, I would say one last question before we slow connection. Oh, ignore. I have a slow network connection. I would say one more question, and then we would just leave it and answer the rest of the questions via email. Can we control a TX and an RX with a third-party controller like Crestron without using a Terra manager?
So without using the Terra controller rather than manager. Ah, okay. So I'm going to answer this in two ways. Yes, you can. You need the manager to be able to set the system up. Okay. You need Terra Manager to be able to assign the IP addresses and create your destinations and video walls and so on, and give names to your sources and so on and so forth. Once you've done that, you don't need that anymore. you can control the whole thing using a third party interface using the API. So what happens a lot of the time in installations is that the customer will be using the API and design their own interface for the everyday user, and the Terra Manager software will be used by the administrator to be able to create the backup files, to maybe update the firmware on the devices or whatnot. So no, you don't need, the Terra Manager software does not need to be running to be able to control the system using third party.
All right.
Anything else, Tom?
Oh, there's quite some more. If we are using 4 multi-viewer video content on one display, we need to connect 4 RX boxes. That's right. If you are using 4 multi-video content, yes. As you said,
what was the question?
I'm still trying to find out. As you said, one RX box can give 4 multi-viewer contents on one display. How does it possible? Oh, no. Oh, there's a misunderstanding on the multi-viewer.
Okay, well, we go into that tomorrow as well, but
that's just a quick hint, because this question came up. What is the limitation of the multi-viewer? 10G bandwidth, once again, is the limitation on the multi-viewer on the RX side. An RX
and also the RX can subscribe to maximum, I think it's 38 sources.
That's it.
So they're going to be very, very small. Basically, the sum of those sources, the sum of those little windows in terms of number of pixels wide and number of pixels high, that needs to fit into the 10G bandwidth. So it needs to fit into 4K pretty much as a sort of a rule of thumb. Okay, so the number of sources, I think it's 38 or 36. I'm not sure about that. I'll have to look that up. But the bandwidth is the most important thing as well. So there are bandwidth considerations that you need to take into account when using multi-viewer. We go into that a little bit tomorrow. Depending on how things go tomorrow, we might actually do another webinar specifically on multi-viewer and how you can use that later on. But yeah, that's pretty much the limit. So 10G inputs on the receiver end and 36 transmitters.
Okay, one more thing. We've been asked if we can share this PowerPoint. So of course this webinar is recorded in total, but will the PowerPoint, will the slides be available for download as well? This is a question that is coming more and more.
Okay. Yeah, I'm going to guess yes. I mean the video is going to be live anyway. So live. It's going to be available. For download for you guys to have a look at or go back to if you need to. So sure, just if you need the PowerPoint, just let us know.
All right. As far as I know, there will be no certification for the participation of this webinar.
No, again, this certification that's for training. This is like an overview of what it is. So depending on how the situation, the medical, the sort of coronavirus situation evolves over the next few weeks, we might find a way of being able to do sort of certifiable online training. I'm not too sure how we can do that, but usually, we certify on-site training. So if you come to a Christie facility and you sit through a training course with hands-on experience of whatever products that you're training on, whether it's a projector or whether it's Terra or Pandora's box or hardware or software, then you get certified on that particular product. We can't do it for a webinar, I'm afraid.
Do you think, do you have the link to sign up for the webinar tomorrow? I guess there will be an invitation and a Facebook post probably
Yeah,
today.
yeah. I mean, it's already out there
So
tomorrow, but we can certainly try and find a way to stick it on the in Facebook again, so you can sign up. So stay tuned.
all right. One last one to close it up. So we buy one controller and use it only during configuration.
No,
Nah.
not true. The controller.
Your turn. Go ahead.